50 years ago, we walked on the moon. Today, we're still launching the same way NASA did in the 1960s, burning billions on rockets that fly once and sink to the ocean floor. But what if there was a way to cut launch costs by 600%, carry 5 times more payload, and make Mars colonization economically possible? SpaceX just proved it's real with Starship V3's full reusable system. The question is, how does catching a 233-foot rocket with mechanical arms change everything we thought we knew about reaching Mars? Here's where the story gets interesting. Saturn V, the rocket that took us to the moon, cost roughly $1 billion per launch in today's money. After each mission, it crashed into the ocean at terminal velocity and disappeared forever. NASA essentially threw away a skyscraper-sized machine every single time. For 50 years, that's how we've done spaceflight. Build it, launch it, lose it. But what if that entire model was wrong from the start? SpaceX answered that question on October 13, 2024, when Mechazila's massive mechanical arms caught a 233-foot booster midair for the first time in history. That wasn't just an engineering milestone. It was the moment spaceflight economics fundamentally changed. Both Super Heavy and Starship now return, land, get inspected in the Mega Bay, and fly again within weeks. The cost savings, hundreds of millions per launch. And here's what nobody's talking about. This forces every competitor to play catch-up or become obsolete. Look at what's happening across the industry. Blue Origin's New Glenn, Rocket Lab's Neutron, and even Chinese rockets are scrambling to add reusability. Meanwhile, NASA's Space Launch System, the $4.1 billion per launch monster, is facing an existential crisis. The White House proposed canceling SLS after Artemis III earlier this year. Congress pushed back, extending it through Artemis V, but the writing's on the wall. When your rocket costs 400 times more than your competitors and can't be reused, how do you justify its existence to taxpayers? But reusability alone doesn't get you to Mars. That's where Starship's second breakthrough becomes critical. And this is the part that separates fantasy from actual engineering. To escape Earth's gravity and reach low orbit, you need roughly 9 to 10 kilometers per second of delta V. Starship carries 1,500 tons of methane and liquid oxygen to achieve that. By the time it reaches orbit, those tanks are nearly empty. There's just enough fuel left to release the payload, not nearly enough for the 6 kilometer per second burn needed to reach Mars. The math is brutal. A fully fueled Starship heading to Mars would need to start with 3,000 plus tons of propellant, but physics won't let you lift that much off Earth. So SpaceX engineered a solution that sounds insane until you understand why it's brilliant. Orbital refueling. Multiple tanker Starships fly to orbit, dock with the Mars-bound vehicle, and transfer fuel in the vacuum of space. Originally, this would require 16 separate tanker flights, 16 launches just to fuel one Mars mission. Even with reusability, that's a logistical nightmare and a massive operational bottleneck. But then came the third upgrade, and this is where Starship V3 becomes something else entirely. Raptor 3 engines generate 280 metric tons of thrust at sea level, up from 230 tons with Raptor 2. That might sound like a modest 22% increase, but in rocket physics, every percentage point of thrust multiplies your capabilities exponentially. Super Heavy, with 33 Raptor 3 engines, now produces over 10,000 tons of total thrust at liftoff, nearly 3 times Saturn V's power. But the real genius isn't just raw force. Raptor 3 dropped 75 to 100 kilograms of weight per engine, while eliminating the external heat shield entirely. The regenerative cooling channels are now integrated directly into the engine structure, which means fewer failure points, easier mass production, and dramatically better reliability. Here's why that matters for Mars. Higher thrust means Super Heavy can push Starship to higher energy trajectories with the same fuel load. Translation: Block 3. Starship cuts orbital refueling missions from 16 launches down to potentially just 4 to 8, depending on payload mass. That's not an incremental improvement. It's the difference between theoretically possible and economically viable. You can now land 100-ton habitats on Mars, deliver enough cargo for a permanent base, or transport 100 people per flight. Things that seemed decades away suddenly become achievable in the late 2020s. But here's the part that's causing panic across the aerospace industry, and it's not about Mars at all. In 2025, Falcon 9 flew nearly 180 missions, a record for any rocket in history. About 90% of all mass delivered to orbit this year rode on Falcon 9, mostly Starlink satellites. It's SpaceX's cash machine, the rocket that funds everything else. And Starship is about to make it obsolete. Falcon 9 carries 24 to 30 Starlink satellites per launch. Starship will carry 100 to 150. Falcon 9 costs roughly $60 million per launch. SpaceX is targeting $10 million for Starship, 6 times cheaper with 5 times the payload. Do that math and you'll see why legacy aerospace companies aren't sleeping well. NASA's already committed beyond Artemis. They've added Starship to their launch services to contract for science missions, exploration, and Earth observation satellites. The Space Force awarded SpaceX $102 million for the rocket cargo program to study using Starship for rapid military transport. Private companies like Vast Space are contracting Starship to launch their Haven 2 station modules by 2028. The market's already shifting before Starship even reaches full operational status. And that brings us to the real battle that's unfolding right now in Florida. Throughout 2024, Blue Origin and ULA bombarded the FAA with comments during the environmental review for LC-39A, arguing Starship is too large and too disruptive. They claimed noise, shock waves, and debris would force them to evacuate personnel and halt operations every time Starship launches. Their real fear: SpaceX flying 44 Starship missions per year from LC-39A, plus more from other Florida pads, essentially dominating the airspace and scheduling windows that Vulcan and New Glenn desperately need. ULA specifically attacked the booster catch concept, arguing that landing at the tower instead of on drone ships creates unacceptable risks for nearby infrastructure. That's when Elon fired back with Sue Origin, basically daring them to take legal action. The FAA released the draft Environmental Impact Statement in September 2025, and the review continues. But here's what changed everything. In December 2025, the Space Force approved the final EIS for SLC-40, authorizing SpaceX to build 2 Starship pads with clearance for up to 76 launches per year. Construction's already underway. So why is SpaceX pushing this hard, this fast, risking industry backlash and regulatory battles? Because Mars isn't cheap, and the window for making humanity multiplanetary might be narrower than we think. Every Starship flight generates data. Every successful catch proves the concept. Every cost reduction makes the next step more feasible. This isn't just about beating Blue Origin or replacing Falcon 9. This is about building the economic engine that makes a Mars colony financially sustainable. Not in a century, but potentially within the next 10 years. The question isn't whether Starship will dominate spaceflight. The question is whether the rest of the industry can adapt fast enough to survive what's coming. So, here's what it all comes down to. For half a century, we've been telling ourselves that space is expensive because it's hard. But Starship V3 just proved something different. Space was expensive because we were doing it wrong. The full reusable system, orbital refueling capability, and Raptor 3's 10,000 tons of thrust aren't just technical achievements. They're the economic foundation that makes Mars colonization possible within our lifetime. Think about what we're actually witnessing here. SpaceX is cutting launch costs by 600%, multiplying payload capacity by 5, and reducing refueling missions from 16 flights down to 4. That's not iteration, that's revolution. And it's happening so fast that billion-dollar competitors are filing environmental complaints just to slow it down because they can't keep pace with the engineering. But here's the deeper question nobody's asking. What happens to humanity if we don't become multiplanetary? SpaceX isn't pushing this timeline because they want to beat Blue Origin. They're pushing because civilizational insurance has an expiration date. Climate change, nuclear threats, asteroid impacts, these aren't science fiction scenarios. They're statistical certainties on a long enough timeline. Starship V3 is the first vehicle in history that makes the economics of planetary backup actually work. That's why this matters. That's why we're covering every development on this channel. If you want to stay ahead of the biggest transformation in spaceflight since Apollo, hit that subscribe button for new space review. Drop a comment below. Are you excited or concerned about SpaceX dominating the industry? And if this video changed how you think about our multiplanetary future, share it with someone who needs to see what's coming. The Mars window is opening. Let's make sure we're ready.